Greetings folks and welcome to the Electromaker show. This is your roundup of all things maker and embedded and lovely. And this week we are looking at the Arduino Plug and Make kit, which is their first foray into truly solderless kits that are very similar to the Sparkfun micromod system, for example, or the Stemmer QT things that Adafruit do. But we'll also be looking at some really interesting projects, one of which is the pairing of the Unihiker single board computer with the power profiling kit 2 from Nordic Semiconductor to really show off how a single board computer can be used to automate tasks during your embedded development. And there's a few really other interesting things we touch on as well. People are trying to completely open source the ESP32 MAC so that you have a fully ESP32 open source radio on the ESP32. And there's a few other things, including a really quite wonderful FPGA based mixing console project that we'll be looking at as well. So with all of that to get through, let's start the show. And we will begin the show by talking about the Arduino Plug and Make kit, which is Arduino's foray into the idea of a very simple development kit that requires no soldering knowledge or electronics knowledge in order to let you get started making things on the Arduino. And of course, Arduinos have had multiple ways to code them for quite a while. You've been able to do, for example, block-based coding on Arduino boards for some time. But with the newer versions of the Arduino R4 Wi-Fi and Minima, you have a powerful 32-bit processor on there. In the case of the Wi-Fi version, you also have connectivity, and the Arduino Cloud has come a long way too. This all comes together to make something that is a perfect beginner kit. And of course, as I mentioned in the introduction, this is by no means a new concept. Sparkfun have had the micromod system out for a very long time, and Adafruit and their mixture of Featherwings and Stemmer QT attachments have allowed you to do pretty much entire prototype builds without having to know anything to do with soldering. It might just be a small touch, but the pegboard that they have is such a nice idea because you can fix your modules onto it, fix the Arduino onto it, and as the promo video that we'll watch in a minute shows, that means you can actually just hang this thing up on the wall. You could technically put together a full home automation setup with something just like this. It is just a Wi-Fi enabled board after all, with a few input switches and outputs, but I think the focus is definitely on novices and beginners, and that is a good thing. So, as I mentioned in the introduction, this is an Arduino kit, and it comes with an Arduino R4 Wi-Fi. However, the kits that come with it, they're connected to it via quick connectors, which is the name Sparkfun used for their solderless connections. But just a quick reminder, this will also be compatible with most Adafruit modules because Quick and Stemmer, or at least Stemmer QT, are completely cross-compatible, and I know that Grove modules are able to be compatible as well. In some cases, you may need some kind of go-between converter connectors, but yes, the beauty of this is that many companies are landing on a similar idea of how to get either prototyping working for professionals very quickly or the lowest barrier of entry for people wanting to get into embedded electronics and programming. Maybe now would be a good time to jump over to the Arduino documentation about it so we can look at exactly what you get with it. And the other thing that makes this kit particularly special, which is that there's already course materials ready for this. On release, you could get this kit and have hours of material to follow on the Arduino website, provided you have an account. So inside the box you get the Arduino Uno R4 Wi-Fi and the pegboard, a USB-C connector and all of the wires and little standoffs you need to use the pegboard and connect things together. The modules are rather wonderfully called modulinos, which I think is a fantastic name for them, but they are very much in the same spirit of the other modules I've talked about in the introduction. These are I2C modules that can be daisy-chained via cable, so you have the one quick connector on the Arduino Uno R4 Wi-Fi, and you can chain the boards out from there, and then of course arrange them in a pattern on your pegboard to use them in whatever situation you wish. And the modulinos you get cover quite a wide range of potential use cases. The modulino knob, I think, is more of a rotary encoder than just a potentiometer, just by looking at the pins on the module. There is also a pixel one which has 8 LEDs on it, and of course you have the pixel matrix on the Arduino R4 Wi-Fi as well, so you have a huge amount of potential output for lights and feedback for yourself. It has a distance module featuring a time of flight sensor, a movement module which is an IMU, and I haven't looked into quite how specific that is yet, but that'll be your tilt, your roll, your movement. Buzzer for generating sounds, and anyone who's messed around with the buzzer and the Arduino tone library knows that you can actually make some quite crunchy 8-bit music through just those little buzzers if you wish. You also get a thermometer, which is temperature and humidity sensor, and one that just has 3 buttons on it which allow you to, well, press, buttons. So that's already quite a wide range of things that you could potentially do with this kit. And one of the official examples, at least one of the examples in the video that they used to launch it, which I'll show you in just a moment, showed a weather system. They had the board hanging by the door, and it shows you if it is going to rain or not. Now, I haven't actually looked into the source code for that, but having made projects like that in the past, you can combine the fact that you have temperature and humidity sensors inside, yes, sure, so you can find your ambient temperature, but you could also call a weather API and use the LED monitor to flash, say, red if it's going to rain, and yellow if it's going to be windy, green if it's going to be a beautiful summer's day, and maybe they'll all flash at once if it's going to be another one of those insane days when it's 5 degrees hotter in this attic than anywhere else in the city of Berlin. Luckily today, I've done quite well. Look at me. I don't look as glistening as last episode. I'm aware that I looked very glistening last episode. It was hot. So in order to stop this section becoming the length of a regular show, I'm going to more or less leave it there. But what I will say is my first impressions of this kit. I haven't had my hands on it yet. You probably saw from the video a rare view of Electromaker Rich, who's not very often seen on camera, unboxing the kit. And my colleagues at Electromaker have one, and they will be making more content on it coming up in the future. My initial thoughts about it is that yes, this is a fantastic learning tool, and yes, this will make a wonderful gift. If I was going to choose a single gift to get people into this, it would be a bit of a toss-up. I think this has a wonderful form factor. I think the only other thing that comes close to it is probably the Grove beginner kit. But they're two very different things, and I would say the Arduino one probably has a lot more support and would be a lot easier in terms of tutorial materials for people to pick up. And the reason I think that is because I've been through the tutorial materials, and everything from going through everything that's in your kit and telling you what it is, down to really little details. Things like this. This is the inventory, okay? And it shows you the Arduino board, it shows you the cable, it shows you all the different modulinos. They've come up with specific icons for each one so that you can recognize them in a pinch, which is going to make writing down and actually just seeing what these things are very, very easy. Because there are, as you know, multiple things you could call every one of these things. This is a knob. It is also a rotary encoder. To someone who maybe had learnt a little bit of language about electronics but is only just on their way in, they might call it a potentiometer, which isn't correct, but it doesn't matter at that stage. However, they know that anything that has this icon is that, and it's the same for everything else here. And for example, that thing I touched on just a moment ago, the weather report, that is exactly what I thought it was actually. It uses an API to grab weather data and uses the LED screen in order to show you that data, or the pixel screen, sorry. So it shows a week-long forecast, and then you can use the knob to select a specific day of the week. And as with all things Arduino, this is a fully fleshed out tutorial with every step that you will need to get it going. And one thing that I've noticed this with almost everything that I've looked at for Arduino, at least not the Pro line stuff. If you do look down at this page, you will see that every single aspect of this has a little label on it that says free content, which makes you think as you get further down, perhaps you'll have to start paying for it, but that's not the case. As far as I can tell, all of the educational materials surrounding this are free to see with a free Arduino account. I did say I was going to play the launch video in this episode. I am not going to, because that would just be extra time. I will link the original launch video for this under this video. And at this moment, I'd just like to take a quick second to say we do not put any monetization on our YouTube videos. We very rarely have any kind of sponsorship whatsoever. So if you do want to get one of these, we do have them in stock in the Electromaker store. Please ignore the fact that it currently thinks it is an Arduino Nano 33B LE Sense listing. That will be fixed by the time you see this video. So if you would like to get one of these as a gift or for yourself, do consider buying it from us. It will support the show a lot. But yes, if I had to sum this up in one sentence, this is among the best starter kits for Arduino and embedded development I've ever seen. And I think people will get a lot out of this, whether they are beginners or more advanced, just by the fact that the form factor is small. You can slot it onto your desk. You don't have to have any tools around you. And it's a very easy way to get started with ideas. I could see myself, for example, revamping my smart home setup, which is laughably weak at the minute, but using this as a sort of basis to get started with, because pretty much everything that I need is encompassed in a few buttons, switches, and a little bit of user feedback. Now we're going to move on to an FPGA project which has an incredible scope. And I say fairly often on this show that I do not have time to go into all of the details of this, and it is especially true for this one because there are so many little details in this project that are wonderful. But the short version of it is that having bought a Behringer Ultranet mixer, this is one that will take an analog sound and then spit it out as a proprietary audio format via Cat6 cable, the creator, Chris Nerding, discovered that this did not work the way he expected. But being an electrical engineer, of course, his idea was, well, let's open the box up and see what we can do. And what he actually does takes him down a journey that incorporates retro computing, one of the most amazing performances showing off a DIY build I've ever seen, and a real deep dive into audio engineering on the FPGA, which of course appeals very heavily to me, that being my main interest in the entirety of the embedded world, as it were. Now, I usually do this stuff at the end of a section, but I'm going to do it at the start because I'm going to go through all of this very quickly. Chris Nerding has a YouTube channel that you should absolutely go to and subscribe. Alongside this project, there's just a whole plethora of interesting stuff if you are interested in music and microcontrollers. He seems to be a very fully fleshed out audio engineer and electrical engineer and microcontroller programmer, FPGA programmer, retro computing programmer, as you will find in just a moment. The GitHub for this entire project is also available. It is in the description of every one of the videos we are about to look at. And the hardware being used here is a Behringer Ultranet, which is a piece of hardware that I described in the introduction, which is some audio equipment that essentially is a very fancy analog to digital converter, but it does a lot more than that. I'm not doing it justice by saying that. But to hack it, he used the MKR Vidor, the Vidor 4000, which is Arduino's FPGA-based board. This puts an FPGA on a board with a SAMD21 microcontroller as a host as well, which gives it a lot of potential functions, as you will see in the coming minutes. So this journey begins with a description of how a mixing board works, and as this little image that just faded off the screen shows, essentially you plug something in, you have a certain amount of DSP you can do to it, or analog signal processing in this case, things like EQ and aux, and then they're summed together into a master channel that goes out. And this is exactly what Chris is explaining at the start of this video. He then goes on to show the Behringer PowerPlay, which is an Ultranet device, which does the same thing, but spits it out as 6 Cat5 signals as well. It is a proprietary digital music data transfer protocol. It is very similar to AES3, and in fact that's something we discussed when we talked to Eli Hughes about his guitar project. These are kind of industry standard ways of sending music data and transferring music data around without using analog cables. Skipping ahead just a little bit, discovering that it did not work the way he expected, he gets the box open and works out quite quickly what everything does, and then uses the Arduino to start sniffing the signals from each one of the output ICs to try and make sense of the protocol. Skip forward just a little way and you have a working design, but that's not before going through and creating various blocks using Quartus Prime Lite, which is, as a non-FPGA programmer, is software I know nothing about, to essentially create a signal chain, a block of signal chains, or several signal chain blocks. Excellent sentence, Ian. In short, decoding and being able to do something with the music signal once it's been converted into the digital realm. I'm purposefully jumping over a few parts here, including how the signal is decoded and the things that are done with these separate 8 channels. It's 2 8 channels over a single Cat6 cable, but the output is done via PCM, and that gives you a full summed master track coming out. And as you're going to hear in just a moment, despite the fact that this is being hacked, decoded, and put back together using PCM, by using the right figures, despite the fact that it is technically a digital output emulating analog, you get a very clean sound.
And it seems to work. Hey, it's fine. We are only outputting with a digital output to a low-pass filter, and we have clean audio output from our FPGA.
And this is where the first video ends. And I know I've moved over this very quickly, but that's because the story does not end here. From here, things just get wilder in the most wonderful way. So we've got to the point where you have multiple streams of audio coming through the Arduino FPGA board, so now what to do with it? Well, one thing I didn't mention from the last video is that this Arduino board also has an ESP32 on it. It's called the Nina Wi-Fi module, but there's an ESP32 inside it. So Chris decides to use that to calculate all of the coefficients for the EQ, which is essentially a kind of filtering. And this in and of itself is very cool. You're using everything on the board. The SAMD21 controller is passing things into the FPGA, the EQ is working, the ESP32 is working out your EQ, but this is where things take a turn for the quite wonderful. Because Chris, as a fan of retro computing, decides what if you could have the interface in OS2, an ancient but much loved operating system from way back in the day running on old Microsoft IBM computers. So I'm going to speed things up even more now because I'm trying to condense 2 very dense 20-minute videos into a couple of minutes on this show, and it's just not going to work. But in short, in order to make an app in OS2, and the idea here is to to have the finished output being able to do some EQing and compression, things that you find in a lot of modern mixing desks. But if you want to do that in OS2, then you need to be able to transfer files to and from the system. And as Chris mentions in the video, back in 1994, there were no USB thumb drives or CD drives, but there were zip disks. The issue with that being, if you would like to use a zip disk on a modern computer, you're going to have a hard time unless you specifically have a converter that will allow you to do it. Which brings us to... How many sounds do you have that are burnt into your mind like that? So yes, back into Windows XP. And this is a way that you can actually transfer files, because back then there was still the crossover between things like zip disks and things like CDs and USB thumb drives. And so this is what is being used to transfer some of the data over. So, having finally found a way to install the app that he created in OS2, and again, there's lots of detail as to how this was done in the main video that I suggest you go and watch, he ends up with this wonderful retro-looking system that is on a retro computer, but that is doing very modern things with the audio. Compression isn't new, EQ isn't new, levels aren't new, but doing all of this in the digital realm is not really something that you could do back in the time that OS2 was being used on computers, at least not in this quality. And there is a lot more to be said and seen here. I highly recommend you want to go and watch the video. But there's one last thing, which is I cannot think of any better demonstration of a project than what happens at the end of this video. If you ever played DuckTales as a child, the end of this video will be wonderfully nostalgic for you, made even more impressive by the fact that Chris plays every instrument. I am so very glad that this video popped up in my feed. This wasn't something I was told about, this was just one of those random encounters on YouTube, but Chris has come up with something very special here, and I think his unique blend of using very modern tools with very retro aesthetics and mixing them with a very true artistic vision, as you are seeing here, is something that will appeal to lots of folks. I'm aware that I've gone even faster than my usual enthusiastic gabble on this particular section. It's something I really have wanted to talk about on the show for a few weeks, but didn't really know how to approach it. I hope that I've managed to do this in a timely fashion and in a way that made sense. If not, I can only recommend going to Chris's YouTube channel, subscribing and watching these two videos, and of course any of the others that interest you. I really look forward to seeing where this project goes next, because I can't see him being finished with this now. He's already come so far, and I wonder if at some point in the future someone will go into Chris's studio and find themselves being mixed on an OS2 computer. It's just such a wonderful blend of the retro and the modern. I love it. So we're going to move on to a combination of two rather nice things that will end up being a very useful tool to many people. So the Power Profiling Kit 2 from Nordic Semiconductor is something we talked about several times on the show before. It is a one-stop shop for profiling the power of your project. It goes hand in hand with the new NPM fuel gauge as well. They both do subtly different things, but essentially if you're really looking for high-level profiling of your project in terms of how much current it's using, with multiple options as to how you power the project, the Power Profiling Kit is something that is very interesting. It also comes with a number of nice ways to automate it, and of course you can do that with your host main desktop computer. But with so many Linux-based single-board computers around, why not use one of those? Enter Unihiker, which is a really unique form-factored single-board computer with an edge connector on the bottom and a touchscreen, which under the hood is a Linux single-board computer. Now, I'm going to spend very little time on the Unihiker and Power Profiler and what they can do, simply because this is something we've done before. Robin put out a Product of the Week video some time ago about the Unihiker, and you can see just how small it is by how large it is in his hand. People talk about credit card-sized single-board computers. This really is that, with a touchscreen on top of it, and as I said, it has that edge connector and a few Grove/Stemmer/Quick/Modulino compatible plug-in sockets on the side as well. I'll also not waste too much time talking about the Power Profiling Kit. I gave a quick introduction to it in the start of this section, and if you'd like to find out more, I'll link the official Nordic Semiconductor page for it there. Now, the thing I want to talk about is this project from CE Tech 11 on the Electromaker website, which combines the two of these things using an unofficial Python API in order to get it working and to really get down into a very very small form factor way of profiling whatever you are doing. So, working in reverse, this is the final output of this project. It is a little temperature and humidity sensor which is plugged straight into the power profiling kit, which is being controlled in turn by the Unihiker and feeding data back to it, showing it in real time on the screen. Now, a quick point here, I believe, I could have this wrong, but I believe the way the DHT11 works is it actually sends digital signals out. This isn't a way to measure the temperature, this is a way of actually measuring how much current the sensor is using in the circuit. As far as I understand, if I have that wrong, please do let me know in the comments how and why I have it wrong. But the project is basically how to get up and running to do this with any Linux computer. The project covers where to get the Python API for it and how to use it with Mind Plus on Unihiker. Mind Plus being their all-in-one IDE for block-based programming and coding. It's a great learning tool, but of course you could do this using any other toolchain of your choice. You could VS Code, whatever. You're essentially installing a Python library. And the PPK is attached to the single board computer via USB. So this is a simple example to get you started, which, as it says, sets the PPK2 to source meter mode, starts measuring, and prints out the average current consumption over several samples that it takes. And this other example turns on the PPK in device under test mode, and then gives every 100 samples back to the Unihiker to display on the screen, which is where we started from just a moment ago. Now, this is a couple of basic examples, and it's using a very specific single-board computer, but there's no reason why you couldn't extend this to almost anything. My immediate thought was if you didn't have a Unihiker, but you did have a Raspberry Pi Zero, even one of the original ones, you could probably get this thing running at quite a clip and have something which is a similar form factor in size, although, of course, you'd have to work out your own screen for outputting the data. And since this is just Python now and you're in code land, you could do absolutely anything with this. You could be gathering data and sending it to a database, you could be gathering data and sending it to an online API. You could be doing multiple things with it, which allows you to essentially have a fully modular, fully programmable power profiling source absolutely anywhere. Now, if you would like to find out more, there will of course be a link to this in the description of the video, along with the original video about the Unihiker, the power profiling kit, and it would be remiss of me to say we do actually stock both the power profiling kit and the Unihiker, although at the current time only the Unihiker is in stock. We are waiting for more of the power profiling kit Mark IIs. It turns out they are in fact rather popular, and I'm not surprised whatsoever. It's a very useful bit of kit. Now, once upon a time, when arcades were the place you went to play computer games, there were various different types of game you could play, yes, but there were also various different ways you could play a game. Of course, we're very used to the stick and buttons of Street Fighter and steering wheels for racing games, but a more forgotten controller was the spinner, which is essentially a little bit like a large rotary encoder that allows you to turn back and forth, and what you're seeing on the screen right now is a recreation of one of those using an optical mouse to track the position of the spinner. It's a wonderful creation by Jester88 and one I saw on the Hackaday blog, and I'm not going to go into too much detail because I don't need to. It's a wonderfully simple implementation of an old idea using newer technology, which is of course something that we really love deeply here on the Electromaker Show. As always, I will link the Hackaday article where I first saw this in the description of the video, and the first link you find in the Hackaday article is through to the Instructables from the creator, Jester88. Now, one of the amazing things about this project is because of the nature of the parts used, there's no microcontroller. This is in fact very simple. The optical mouse is doing all of the work here. The real beauty is in the build itself. Because by taking apart the optical mouse and then shaving off a little bit of the board in order to make it fit, he was able to then rewire it. So all of the mouse buttons, including the scroll wheel, are rewired. You have to wire all of those up for this particular mouse for the mouse to function. So then you're left with a broken out mouse board with a lens that would usually point down to the table, and when you move the mouse, it detects that movement and then reflects it on the screen. And the way that this actually all comes together and works, well, these are all the buttons being added, but the real joy of it here is you have a bearing and you have that knob fitting into the bearing, and then in order to actually watch it going round, they painted the drum because the white surface doesn't work particularly well, and so they've roughed it up so that it's like a rougher surface of a desk so that the optical mouse can actually see when the thing is turning or not. And once you have this going, you essentially have a mouse in a different form factor, which depending on what emulator you're using means it will just work straight out of the box. And as you're seeing, this is using the spinner with MAME right here. I am going to keep it this brief. There's not much more to say other than this is simple but wonderful, and the beauty is absolutely in the build and the implementation. I'm really glad I saw this, and it gives me a lot of really interesting ideas as well. Really long-time viewers of the show will know that for a while I experimented with making a completely custom handheld piece of hardware for video editing, which involved a spinner for moving backwards and forwards through various different things. Seeing this approach makes me wonder whether there are other ways I could incorporate actual normal hardware, like say, for example, the board from a keyboard, and make use of that instead. It's something that is a very interesting prospect, and yeah, just simplicity coming out with something wonderful like this always appeals to me, which is why I thought it would appeal to you as well. We're going to move on to an attempt to open up the ESP32 MAC. Now, the ESP32 is a much-loved controller for pretty much everybody. It's very powerful, it has Wi-Fi and Bluetooth on it, but the firmware for how the Wi-Fi and Bluetooth work is closed source. And while Espressif have been very good and given many ways that you can work with it, where there is closed-sourced firmware, there will be someone that wants to open it up and create an open-sourced version by reverse engineering it. And Jasper Devriker, whose name I hope I'm not mispronouncing, is one of those people. Now, this is one of those times when I would suggest maybe if you have an e-reader or a Kindle, downloading all of these and sticking it on there. I have only gone through the very first part of this so far. I've taken a glance at all of the rest of it, and a lot of it is very much over my head, but it is very interesting, and it has been my evening reading for what time I have had to do that recently. But I will leave a link to this particular page that gathers everything together. The first two parts of it are actually on a different blog, and essentially, if you want to get a taste for what this is like and whether you will like to read it, reading the first part of part 1 is a very good way to do it. It says more or less what I've just said. It's a very popular microcontroller known for its low price and very useful features. It does have a closed source Wi-Fi implementation, however, and there are several disadvantages. A, being dependent on the vendor, so if you have an unusual use case, for example, you're going to be out of luck. You can't spool that up yourself. It's very difficult to audit the security of a closed source implementation because you just have to basically guess with what comes out of it, and you don't really know what's going on inside. And finally, an open source implementation would make research into low power Wi-Fi much more easy. You don't have to actually buy into any kind of system. Open source is, well, open. The rest of this first blog post goes through the goals of the project and previous work done by other people, the tools that are going to be used, and it ends up with being able to, pretty much from scratch, send some packets of information. And that's where this one ends. But there is a whole bunch more in this series, including one of the talks at the Gulasch Programmernacht 2022. Speaking two languages is weird, all right? At the 22nd Gulasch Programmierenacht, which is something I hadn't heard of before, but you can find the slides to that talk there, which might also be another really nice way of getting introduced to this project. But I know that many people are very supportive of these open source projects. They really like the idea of it being opened up. This is one of the few times when I'd reach out to our audience and say, if any of you out there are really hardcore networking engineers who have worked with hardware a lot, who may want to, be a part of contributing to this project, take a look at it. The blog post here will give you everything else you need to get started, and there is also a link to a matrix room for the subject as well. And it's so much above my head at this stage that I'm reading this purely for entertainment, but I can imagine, especially those who are deep in these technical details already, seeing someone step through a black box system and try and reverse engineering it will be something very satisfying for you. And so far, this project has been ongoing for quite a while, and I'm very much looking forward to seeing where it goes next. So that has been our show for this week, and I am very aware it has been a whistle-stop tour, but every now and again there are so many interesting things I want to talk about that I just like to get the information out there. I hope that at least one of these projects will inspire you to go and look at the source of the project, learn a little bit about it, maybe try and recreate it yourself, or just reach out to the creator and say, well done. The sharing of these things online is the thing that got me into this in the first place. I only really got into the whole embedded side of things through the fact that there are so many people talking about the things they were doing online, helping each other out, providing example code which allows other people to learn and use that example code as a springboard, and this is something that applies pretty much across everything, as I'm sure most watchers of the show will know. Thank you for your continued support, whether that's by liking this video and making sure you're subscribed to our YouTube channel, or by going to the Electromaker store and buying whatever you need, or maybe a gift for someone else. We've covered various things in this show which cover all spectrums of the electrical engineering and programming world, everything from the very same board used in that FPGA mixing console through to the Arduino Plug and Play kit, Plug and Make kit, and various other things available in our store that support us financially and directly. And I think that is it for this week's show. I know there's been a smaller gap between shows this time. I'm trying to catch up. I'm really enjoying being back home and talking about everything again and having a little bit more spare time, a slightly more rational timescale in order to get these shows out. I hope it is showing in my my enthusiasm and general talkiness. And once again, apologies if I go a little bit too fast for the non-English speakers. It is something I am constantly trying to work on, but a lifetime of being a very fast talker is something that is a habit, and habits are hard to break. Anyway, that's a rather long outro, isn't it? I hope you're having a fun, safe, and creative week, and I'll chat to you all very soon.